everything. It causes mold. You have to replace the entire floor, subfloor. If it's on an upper level, it gets down and drips down into other floors. So you can imagine the cost for cleanup with water would naturally just be higher. When we look at the money spent, water damage accounts for about $9 billion. And again, this is an outdated figure at this point. This was a study done by the American Insurance Institute back in 2007 to 2009. And at that time, they figured that amount, which was about a quarter of all property loss suffered by homeowners, was from water damage. Now, just to clarify this, we're not considering environmental flooding, the river rising, the hurricane coming through and destroying the whole neighborhood. These statistics are purely just water damage from aging and old appliances in the home or user error or something happening specifically to a house, not from the environment. So that study also showed the average cleanup cost for water damage repair was just over $20,000, and I imagine it's really only gone up since. What's the cause? Leaks and water damage. The study showed the main cause is aging appliances, pipe failures, frozen pipes, things that nothing lasts forever in this world. So when you look at what could be the cause of it, anything that uses water in the home is a potential possibility for a leak. It just actually happened to me. I moved out of state, and before I moved into my new property, the landlord calls me and says, "Hey, I've got bad news. The basement flooded." And in this case, it was the refrigerator supply line, the water line, that little plastic tube had a pinhole in it. So who would have thought of that? But this kind of stuff happens. And it was enough to flood out the entire basement. And again, it was an unoccupied property. He was just waiting to rent it, and he comes over there after 2 weeks of not being there, and the whole carpet's soggy, wet mess in the basement. And all from a pinhole in a quarter-inch line going to the refrigerator. It's getting worse. So when we look at the growth of water leaks as components of homeowner insurance claims, it's only going up. It's the fastest component rising. And if you look at the infrastructure and the regulations and all the industry on homeowner and municipal code, there's very little out there about preventing water damage. There's lots about carbon monoxide, fire. Everybody has to have a fire smoke alarm in a home. Suppression systems are becoming common as new plumbing code, especially if it's a larger property. If it's commercial, you have to have fire suppression systems. But nobody's thought about water until now. So really, there's a great opportunity in the industry to get the infrastructure updated, to modernize homes with water damage prevention systems. It's already happened in Europe. If we look at some of the countries, Norway, Sweden, Finland, the northeastern countries there, the government's actually, with every new building, you have to put in a water damage prevention system. That's now part of their building code. And so it's really starting to catch up across the United States, and a lot of builders are starting to putting in these systems as standard, and gives the homeowners opportunities to upgrade and make it smart, add it into their home automation system or security system. So this is really where we come in with our solution. Our solution really has three main components. We have sensors. The heart of the system is the shutoff valve, and our flow meter. And so I'll talk about all three here. But really the overview is we don't make our own controller. Our solution is not a standalone. We depend on automation systems, security systems, such as the smart things that Richie opened up with. That's a really great platform that's open for us. We wrote our own device handlers, and the user experience is really nice with smart things for all of our products. So first, you pick your smart home automation hub. You set that up. I'm sure most of you are familiar with how to do that. And next, you'd want to do your plumbing. So plumb the valve on the meter. You got to find your water main. We suggest work with a professional plumber. Again, it doesn't have to be a specialty plumber. Any plumber can do this product. Any plumber that can do the most basic of plumbing jobs will do it. Just the added thing is make sure this plumber knows the local plumbing code. If in your local area you need to have dedicated shutoffs for a fire suppression system, for example, or if you need to have a dedicated line for inside the house and another one that goes to the outside for irrigation use, that's all things your plumber needs to know so that you're plumbing your product legally and properly so that you don't have any issues. You can only imagine it could be a nightmare if you put this in yourself, you put it in incorrectly. Say your house has a fire suppression system in and you put a shutoff valve before that system splits off, and say you have a fire, the smoke alarms detect the fire, the sprinklers go off, the sprinklers get the floors wet, the water sensors detect the leak, shut off the water, and what happens? The house burns down. So a lot of liability there. It has to be done correctly. We always recommend work with a professional that understands the local plumbing code, understands how the building is plumbed, and can help you with the installation side of it. Really, the simplest is the installation. You can use any type of water main product. You can use just traditional copper. Our products work with CPVC, works with PEX, and you just have to buy the appropriate fitting that would go with that water line component. So once you're done with the hardware installation, then you install them into your network. You install the sensors throughout the home. And again, we suggest if you're a dealer, work with the homeowner directly here. They're going to know which areas of their home might be more prone. They might know, hey, this toilet's pretty old, it's leaked before. That kind of stuff is good to know because they're going to put a sensor where they think that are the most common places where they can have a leak. And then last, you want to create some rules and automations. Obviously, the simple ones would be sensor becomes wet, turn off the water. But with the flow meter coming online as a new product, you can also create some automations based on your specific lifestyle. It's really nice. You can set some rules and automations for that. I'll go into detail when we get to the flow meter. Okay, so the sensor. Our sensor is a simple rectangular piece. It fits in the palm of your hand, pretty small. It works on 2 AA batteries, and it's really just as simple as learn it in and place it on the floor. On the face of it, it's got a program button. This is just used for Z-Wave programming. Get your hub into network inclusion mode. Hit the program button. Pairs in. It'll show up in your interface. And again, you just set it right on the floor. Here you can see, just highlighting the section here, that's the sensing element. So that has to be where the water touches. If those two get wet, conducts, and it will trigger alarm. This will not work placing it directly onto a pipe, because if you place it directly on the pipe and those two are touching, it'll always read that it's an alarm. So we always suggest just place it right on the floor at the appliance or nearby where water would create a puddle and get to the sensor. We have 2 different versions. One's with a buzzer and one's with an LED. This first one that I showed you here was just an indicator LED. This one is completely silent, does not make any noise when it's an alarm. This sounder version will make a low drone beeping noise sound that, again, it's useful for users that if you're in the property and you want to find your way to which sensor is tripping, you have multiple sensors, this is a good way to find it because they'll identify themselves by their sound. Again, if you're not in the home, there's no point to hearing it because you're not going to. So, but they're both exactly the same. They react the same. One just has a buzzer, one One just is completely silent and has an LED to let you know its network status. Common applications for the sensors. Again, we suggest work with the specific homeowner and find out what are their hot spots, where do they think that they can have issues. The obvious thing is if you do a walk through the property, if an appliance looks old, that's definitely a place to go put in a sensor. If it's a brand new build construction, you can just go with common applications. But really, this is custom made to each home. So some of the common areas would be dishwashers, water heaters, toilets, nearby sinks, under the cabinets. Anywhere where a supply line would come in, it's a great place to put it. Even attics where the AC drip pans, the AC units in southern homes are typically up in the attic. If those clog up and overflow, you want that sensor to turn off the AC system and stop that pan from overflowing. So sump pumps is another great application too. Okay, so the water valve. We have two main versions. This one that I'm showing you here, this is the indoor unit. This is our traditional unit. And just to go over some of the highlights here, you can see this is our ball valve. This is the portion that gets plumbed. Again, it's a common lead-free brass ball valve. It's similar to what you'd get at the hardware store, except the connector head is made specifically for our actuator. And it is an automation-grade valve, meaning it's not a gate valve. It's a completely pass-through, and it's intended to be opened and closed many times without wearing out the seats and the seals. The enclosure is NEMA 4 rated. What that means is it's weather resistant. It could be rained on. It could be temporarily splashed. Although this unit we do not recommend putting outside. The electronics inside cannot handle freezing conditions. They cannot handle sitting out baking in the sun in Southern California. So this unit needs to be installed in a dry location inside the home where it's a temperature-controlled environment. A garage would also be okay if it's a heated and air-conditioned garage. So on the unit itself, you've got buttons, you've got a program button, you've got open and close. So really this acts as your panel. You never have to open and close your water manually anymore unless there's complete power loss. Some folks even completely replace their existing ball valve with this one and just use this as their primary shutoff and eliminate the manual handled version altogether. If there's a complete power loss, you can still turn it manually. There's a manual handle on top, and it shows you at the top of the unit which position you're in. Otherwise, you just plug this into a regular 110-volt outlet, and that's a 20-foot cord. So even if you don't have a plug nearby, as long as you can stretch that cord within 20 feet to another plug, you can reach it. Otherwise, an electrician would need to be brought in and put in an ejection box. There is an option for a 12-volt DC battery backup. Again, we recommend this if you've got a automation system that's also battery backed up. Find a way to get this battery backed up as well, and you don't have to worry about power loss situations becoming a problem. A lot of times, if you live in the Northeast, for example, everybody's got sump pump wells. If your power goes out, your sump pump can't run. That can overflow. You've got a flood in your basement. You really need to have a battery backed up power source or a generated backup power source if you live in the cold climates where you have basements with sump systems. And yeah, so enough about that. We also have a wired probe. It's not shown here. There's a picture a little bit later, but that's just one extra water sensor. If that gets wet, it will automatically override and turn off the water. So a little bit about our methodology. Some of you know we've got competitors. There's a few ways to create actuators for shutting water on and off. Our method doesn't go the clamp route. Clamping systems have proven to be unreliable because they work themselves loose or they'll crack the existing ball valve. You want to make sure you're using an automation ball valve, not a gate valve or a ball valve with a handle that who knows how old that thing and rusted it could be. Our method is we're going to make sure we use a quality ball valve that gets plumbed at the time that you put this installation in. And if you look at some of the components here, we do not directly connect, here's the ball stem, we do not connect the stem directly to the motor, because what happens is if you look inside water pipes as they age, you get sediment deposit, calcium buildup. It's not a clean, completely clean environment, and all that deposit on the outer lining of the wall just creates things to seize up. So if a ball valve hasn't been turned, sometimes you go into some of these old homes and you cannot turn that thing loose. It takes quite a bit of torque to break free that sediment to get that water back on or closed. So we use a 24-volt DC motor, and it's paired to a gear reduction here, and we multiply that torque quite a bit, and we have a lot of force to turn that ball. And again, we don't want to come out of alignment. Some of the other competitors I have use clutch-based systems. The motor's directly connected to this through a clutch system, and they'll slip. And if they slip, what happens is you think you're close, but you're not all the way close. That ball is just peaking, and it's letting some water through. And then they got to be realigned, and it causes issues. So we really think our design is the best out there, and we're pretty proud of that. All of our components are rated to 250,000 cycles. Believe me, you'll never get to that. You'll never use 250,000 cycles in the lifetime of even your home. So you just have it open and close once a day. You'll never get there. It'll take like 200-something years. So here's another picture on the right of how we connect. We're a free-floating actuator. We could be mounted vertically or horizontally. Doesn't matter. We do not put any torque on the ball valve. We don't put weight on it. We just connect to the housing, and we turn it with our actuator at this point here. And it is sealed with an O-ring so that there's water not intruding inside. So this is our outdoor water shutoff valve. We added this variant last year. Really, the benefit of this unit is where you do not have access to water mains, and I've got a slide coming up about where these would be put. Where you don't have access to your water main and you have to put it outside the home, this is great. It's going to save a lot of labor, breaking the drywall and finding a way to get to that water main. This works well in southern, southwest states. Anybody that's not in the freeze belt, you typically have the water mains outside. They might be put in a meter pit outside in the front lawn under one of those green boxes. So in those installations where it's much easier to find your water line coming into the home outside, you could use this product. So what we did was we took our indoor unit, which had the ball valve connected here, and we separated all the electronics and we moved them out in its own separate box, and now this portion goes outside and with the ball valve, and this portion goes inside, and we connect to it with a UV-rated, outdoor-rated cable. You still get the same benefits of having your Z-Wave inside. You don't have to worry about connectivity issues and going through outside walls, and you can run this as far as you need to. We make it 3 different lengths, 25 feet, 50, and 75 feet. And at the installation site, you would just trim it to length. The outdoor unit is NEMA 6 versus the NEMA 4 rating for the indoor unit. NEMA 6 gets us to completely waterproof. So you could put this in a water tank and water will not get in. It's the NEMA 6 rating allows for occasional temporary submersion at a limited depth, which is 1 meter. And so, again, they work good above or below grade, outside in the elements. Ball valves. talked already a little bit about the ball valves. Really, the key to a good ball valve is make sure it's high quality brass, and we have to, in the United States and Canada, pretty much all states have updated their plumbing code to use lead-free. Although I believe you could still buy just standard brass valves at Home Depot, you want to make sure you get a lead-free ball valve. We make it in 4 different sizes. It seems like my presentation got a little mixed up here. But between 1/2 inch and 1 1/4 inch, we're covering 90-something% of U.S. households. Most households actually have a 3/4 inch water main or a 1 inch, and larger properties would have 1 1/4 inch. 1/2 inch is for plumbing individual appliances or lines, and these ball valves are rated for both hot and cold water. So if you really want to go all out, we've had customers that plumb their cold and hot to the showers, and they can control their kids from taking 30-minute showers by just turning off the hot. You know, they think it's funny. So here's a little bit about determining the location. This one shows what a typical supply line would come in the north, where you have your meter and your water shutoffs inside. Again, this system is, when they have freeze, they protect from having things crack and break by having everything below the frost line. So they've got typically a curb stop. Your water main is whatever feet down that your local code provides for, so that you're below the frost line. And so here's your city main. Water comes in. You've got that curb stop, and then it comes up and above into either a crawl space or a basement, where you'd have your water meter, and this is your city's meter that they would read. You've typically got service valves on both sides, and then it goes on into the home. So really, you want to put in the ball valve and your own meter anywhere downline of here. You can put it wherever you like. Some people replace an existing ball valve. Some people just, if you've got the space, you just put it in line. Here's what the outdoor looks like. It's a little bit more complicated. Same situation, you have your city main here, tap in. Again, these things, because they don't have to worry about a frost line, these things could be just maybe 1 foot or 2 underground. They might have a meter pit in their front yard or at the curb, where you can access that, and you could put the water shutoff inside that pit if you've got space. Again, you could replace maybe just one of the ball valves there, or put it in line. Sometimes they might have another service shutoff in a different pit, either under the ground or right at the side of the house. For example, in Phoenix, we're running a big pilot right now. All of their shutoffs come up about 3 feet off the side of the house and then go in. And this is the location that we're putting all the water shutoffs in. So again, even if you have this situation, but you've got access, they've got a basement, or you've got access where you could put in a water valve inside the home, we still recommend using the indoor unit. It's cheaper, the installation goes quicker, you don't have to run a cable. Otherwise, if you don't have access inside, if it's a condo, if it's all closed in, by all means, then go outside and put it where you'd have an easy installation. And by the way, guys, if you have questions, just write them in the chat box, and I will answer them either as I go or at the end. Flow meter. A couple of statistics. This is from the American Works Association Research and Foundation. I think it's on the EPA site that I found this. I find it interesting of how much water is actually leaked, but not leaked on your floors, or that would be considered a water damage claim, but water leak based on appliances that are defective, a toilet running, a dishwasher that is very, very inefficient, right? It uses way too much water, or it's something's broken and water's just going through its supply and drain, all sorts of stuff, leaky faucets, that kind of stuff. So we look at how much water do we use. They did some statistics on this, And I found it interesting that 14% of our usage as Americans is leaks. So take your water bill and take an average of 13% and figure out how much is that in dollars for you that you're just throwing away and it's not even usable. Common things that we hear, we launched the flow meter last year. People are finding out right away, they put them in and they realize they've got a toilet that's been running. Or I got a guy that called, and it was kind of a funny story. He's like, hey, I've got 2 teenage daughters. I never go in their bathroom. You just don't do it. And he puts it in the flow meter. Automatically, he finds out that there's this constant flow somewhere. Something's not right. He checks the whole house. Then he thinks to check, you know what, I'm going to go in their bathroom. Looks in there. They have the toilet. The bobber was just off the chain that slipped off, and it just constantly was running. And they didn't tell them. These kids, they don't care or know, and it can be a very, very expensive bill. We've heard of 90,000 gallons over a course of 2 weeks, causing a $1,000 water bill without the waste removal. So, not a cheap bill. I think it's something to think about. A lot of homeowners are starting to think about how can we save on our water consumption, because it's really starting to hit the pocketbook. It's beyond the let's save the whales and live a green, environmentally friendly life. This is getting expensive. Out west, where they've got drought, the average water bills are on the rise. Multi-unit dwellings, apartment complexes, they're having problems because of rent control. They don't allow them to raise the rates, the rental rates beyond a certain percentage, but the water bills are going up faster than that percentage. So these property owners are finding themselves in a bad place because of water. So here's our product. It's very simple. It's just a meter. We use a traditional impeller-style meter. The meter body connects to our interface unit, which has our Z-Wave radio and electronics in it. With the data cable, we use a micro USB. This picture is actually a little bit old, but the micro USB cable plugs into the bottom of our unit, and that unit you just pair to your wireless network like you would any other device, plug it into the wall, and as that meter turns, we count data. We count gallons, and we tell you some basic things, right? As soon as water is running, you just get a simple notification. Water's on. You could choose to ignore that every time it happens, but you can have it set. So, for example, if you're away on vacation and nobody's supposed to be in the house, and all of a sudden the water starts running and it's not supposed to, you can have that as a water leak alert. And you can have it do an action such as turn off the water, right? And so you can create rules and alerts, send notifications with several different modes. These modes are specific to SmartThings at the moment, but we have other systems coming online that would have similar use cases and applications. So, for example, overflow detected, meaning too much water is flowing. It's too fast, right? Maybe your appliances, you do a quick study, your appliances don't use more than 8 gallons per minute, but all of a sudden you get a detection at 12 gallons per minute. You might possibly have a burst pipe. The other options would be, say, continuous flow. One common thing we do is let's just set it up for an hour. An hour is a good standard. If water is running continuously for more than 1 hour, that's probably not a good situation. If you think of your water usage as a typical, home, you might take a shower, you run the dishwasher, flush a toilet, run a sink. But all those are just quick events, maybe up to 30 minutes on a shower, but nothing's supposed to run continuously for too long. Everything's always going to go back to a zero flow and turn off the meter. Well, if an hour is detected, maybe a toilet was left running, right? So that's your way to check for that. Maybe you got a neighbor that's using your garden hose that shouldn't be and knows you're away from home. So that's the kind of stuff that you can create rules for continuous flow. I had mine set for an hour when I was home and for 20 minutes when I was gone, because we didn't want to turn off the water every time we left. We might have left the dishwasher running and it needs to run the rinse cycle. So 20 minutes was enough to let it finish whatever it was doing. And accumulated flow is also another one. If you want to set goals and limits, say, you know what, 100 gallons per day is our total allowable limit. So you just set it so that within a 24-hour period, the meter looks for 100 gallons. When it gets to 100 gallons, it can either turn off the water for you or it can notify you and you just know. So really there's quite a bit of capability that the meter can do in terms of just data, giving you data that you can use for automation. I see here Jim wrote a question, what about digital water meters? So our meter, our flow meter, you have to purchase our flow meter body along with our interface. It's all as a kit. The reason we did that is it's impossible for us to take data from many different types of meters, digital ones, or even analog. We count pulses, and so our unit is specifically calibrated to the specific meter body. So we get 10 pulses per gallon. Other meters might be sending something else. They might be sending a digital signal in that case, or multiple pulses, or even one pulse per gallon. And if you were to try to hack and just use the interface, you'd get inaccurate data. So again, they come as a kit, and you would install them together. Use cases. So again, we're of the opinion every home should have a prevention system in place. They're really, at this point, when you think of all the technology within a home, all the things that would use water, 50 years ago you might have a 4-bedroom house with 1 bathroom with a tap at the kitchen and at a bathroom, and that was it, and your water heaters in a crawl space or a basement. Now you've got much more infrastructure in terms of water within the home. I was just on the phone a month ago with a big manufacturer. They make microwaves, and they were telling me that their new microwave coming out next year is going to use water to steam your food. Interesting. But this proves the point that water is just, it's useful, and there's many places within the home that everybody has them. And like even here with our, we just moved and we got some new washer and dryer sets. The guys are installing them for me, and I go over there and I'm like, what are you doing? Why are you putting a water line to my gas dryer, the clothes dryer? It's like, well, you've got the steam function here, so it needs a water line. I found that interesting. Like, okay, so now I need water to dry my clothes. So again, the point is the complexity and the possibility of water finding a way to leak out, breaking, a seal goes loose, an O-ring fails, something happens, the possibility that floods are going to occur in just the average single-family residence, condo, apartment, that's all on the rise. I think it's a great opportunity to put in the infrastructure to stop that from happening or reduce the damage when it does happen. So, yeah, vacation homes and rental properties, they allow remote control of the water supply. We have customers that buy them just for their vacation and rentals. They use it as a gatekeeper. So when their tenant comes in, they turn on the water automatically, and when they leave, they turn it off. They don't use sensors. They don't use the flow meter. It's just the water valve as a simple gatekeeper to turning on and off as they occupy or leave the property. Multi-unit dwellings, condos, and apartments. This is really beneficial for larger management firms. It allows you to employ less staff. If you can imagine, right now a lot of situations where, say, there's 10 units, apartment units in a building. The building only has one water main that supplies all of them. And so if they need to do service, if they got to fix somebody's refrigerator or whatever it may be, changing out a water heater, they have to turn off everybody's water. you can imagine that gets annoying if 1 week they're working on one guy's and the next week another guy needs his work done and you're without water for hours upon hours a day while the staff's working. If you can just sub-meter these, if you could put in shut-off valves on each unit, now you're not disturbing the individual tenants and you can employ less staff. You don't need to have 15 people on site to get in and out in 3 hours because you can't legally turn off their water for 24 hours. A lot of places have them. So allows you to save money. You put up investment into this equipment, you can save money by employing less staff. New home construction. We sell the ball valves separately. So you can purchase these from Worthington with just a simple manual handle. And if you're working with builders, convince the builder, instead of going to Home Depot or their plumbing supply house, go and just get our ball valve that works with our actuator. And so they put these in as standard, and when they get a homeowner in, that's the opportunity to upgrade them. If they go for it, then you purchase just the actuator, put the system in, and we don't have to do the plumbing again. And if they choose not to, they still just got a plumbing shut-off valve with a manual handle, which is what they would get normally from a standard builder provision. That was it for those. We've got some other devices. I want to put them on here. Feel free to visit our website. We also make other Z-Wave accessory devices. We make simple sounder strobe alarms. This is our SSA1 with a clear lens fuse with the red. This is our SSA3. It's got a digital sounder. You could put this one outside as well. And we also make some dry contact relay modules. We call them IO modules, MIMO Lite and MIMO 2. These are very nifty devices to basically turn anything that would be a wired device into Z-Wave. You could control a motorized gate, a door, such as a garage door. You could put in any type of a sensor, a low voltage sensor, either a digital or a analog sensor, and you just say somebody presses the doorbell button, you can get a notification through Z-Wave that your doorbell button was pressed. So these are again popular devices people want to use for DIY applications, and where a native Z-Wave solution might not exist, you can use this to make it happen for your application.